Yes.
Okay. So trigonometry is about the three angles in a triangle. Okay, that is what we are going to discuss. Okay, let's get started. So today's topic is trigonometry. Especially today, we are going to see the angles and the relationship between the angle and sides in a right angle triangle. Okay, that one. But you know about one concept. What is the concept? In a right angle triangle, with the side, there is a relation between the side measures. What is that relation? Do you know that?
Pythagoras theorem.
Exactly what it says. What is Pythagoras theorem?
Square of the two sides is equal to the square of the hypotenuse.
What is hypotenuse? How do you fix hypotenuse?
The longest side.
The longest side. Okay. If you don't know the measures of the longest side, then how do you fix?
Opposite to the right angle. The side
Very
which
good. Yes, brilliant, brilliant. Okay, dear. So then now we will see the relation between the angles and the sides that we are going to see. For that, I would like to introduce trigonometric ratios. Okay. Trigonometric ratios. There are six trigonometric ratios are there. What are the six? Sine theta. Theta, it means angle. Actually, it is sine, S-A-N-E, but we don't write that way. We write sine theta. And cosine, this is also we write cos theta. And tangent, but we write tan theta. And if you put the inverse of it, 1 by sine, that is called cosecant theta. Cosec, we name it as cosecant theta. Similarly, 1 by cos, inverse of cos, that is secant theta. Actually, this is cosecant. This is a full name, but we mention cosec theta. Similarly, this is secant. Okay, we name it as sec theta, and 1 by tan, that is called cot theta. Cot is cotangent. Actually, this is cotangent, but we in a short form, we mention cot theta. Now we will learn how to calculate these angles using the angles in a right angle triangle. Okay. Okay then. If you take a right angle triangle, I name the vertices A, B, C, and this is at B, it makes 90 degree. Then if I consider this angle as theta, the side which is opposite to theta is considered as opposite side. Okay, this is opposite side and the adjacent to the angle. This is adjacent side. And there is no change with hypotenuse. Hypotenuse is fixed. This is hypotenuse. But if you consider the angle A, if you consider this one, I draw in separate triangle, that would be better. Okay, same triangle, ABC. And if I consider this angle A, then this becomes opposite side. And this is adjacent. And this is hypotenuse. There is no change in hypotenuse. Okay. Then what is the ratios? How do you find sine, cos, tan? That we will see. Sine theta is equal to opposite side by hypotenuse. Okay. Then cos theta, that is adjacent side by hypotenuse. And tan theta, that is opposite by adjacent. Okay. Then this is a formula, but tan theta you can write another way, that is sine theta by cos theta. Then cosecant, secant is what? Inverse of sine, cos, tan, isn't it? So cosecant theta is equal to inverse of 1 by sine. So that is hypotenuse by opposite. And secant theta can be written as 1 by cos. That is hypotenuse by adjacent. And cot theta is equal to 1 by tan. That is adjacent by opposite. In other word, excuse me, cos theta by sine theta. Okay. So in a short form, if you remember, mainly you see this, you can remember by a small trick, sokata. So ka cha. You remember this way. So sine, opposite, hypotenuse. Cos, adjacent, hypotenuse. Tan, opposite over adjacent. So if you wish to remember with the some small trick, you can remember this way. Sokata. To remember the ratio. Sometimes if often it confuses, for that you can use this trick to remember. Okay. Okay, then. So how to do sums based on this concept? Let's see. Okay. Guys, if you have any doubt or not clear, you can ask. Okay. So this one, in triangle ABC, right angled at B. See, better you always picturize the sum to get better understanding. Okay. So here right angled at B. So you name that right angle part B, and this one AB or this is AC, you can name that as it is not an issue, but at right angle, it's supposed to be B. The vertex to be named B, and AB is 15. This is 15 centimeter and AC is 17 centimeter. Find all trigonometric ratios of angle A. So before finding this, you first find this. Okay. Before that, no angle is given. So first you have to find the angle. First we find the angle. So according to this angle, this is adjacent side, isn't it? According to this angle, this is adjacent side and this is hypotenuse. So the relation between adjacent and hypotenuse is what? Cos theta, isn't it? So cos theta or cos A, find all of angle A. Okay, so we name it as A instead of theta. That would be better because you have to consider the angle A. Okay, cos A is equal to what? 15 adjacent by hypotenuse. So before that, what should you do? You have to find the unknown side. How do you find unknown side? What is the idea? You have exactly. Very good. So AB square plus BC square, that is equal to AC square. Just you apply 15 square plus BC square is equal to 17 square. Then BC square is equal to 17 square minus 15 square. As you are not allowed to use calculator, you can apply identities to simplify the calculation. This is A square minus B square, right? You can apply A plus B, A minus B. That way, the calculation will be easier. So what happens? This is 12, 1, 32, and this is 2. Then what happens? It becomes 64, isn't it? So BC square is 64. What is BC? That is 8 centimeters. Yes, very good. So this is 8 centimeter. Now you can figure out all the trigonometric ratios. One by one will go. Sin A is what? Opposite by hypotenuse. 8 over 17. Cos we found, isn't it? Cos A is equal to 15 over 17. And tan A is opposite by adjacent, that is 8 over 15. Then inverse, cosec is, yes, dear. Yes, come again. Got any doubt?
No, ma'am.
Okay, fine. Okay, cosecant is 1 over sine, isn't it? So it's just inverse of it. Yes, 17 over 8. And secant A is 17 over 15. And cot A is 15 over 8. That's it. I hope you got clear with this concept. Let me check, is there any tricky sums there? I think. Okay, we will see this one. So the figure is given in the sum. Okay. Now we will see how to solve this. You have to find these values. Sine A. Sine A, according to this angle, this is adjacent side. This is opposite side. This is hypotenuse, isn't it? So before starting this one, you're supposed to find AC. So you consider the triangle ADC. So you have to start this way. Solution. So which triangle you are considering? So that should be written. Triangle ADC. AC square is equal to AD square plus DC square. Apply the values. AD is what? 6 square plus 8 square. That is 36 plus 64. That is 100. So AC is 10, isn't it? So this is 10. Okay. Then sine A is what? Opposite by hypotenuse. 8 over 10. You can simplify. So 4 over 5. Yes. Then the second question is cot A. What is cot A? Adjacent over opposite, isn't it? Adjacent over opposite. What is adjacent? 6. Opposite is 8. Again, you can simplify the fraction. 3 over 4. Then tan B. So tan B, if you consider this angle, this is adjacent. This is adjacent. This is opposite, and this is hypotenuse. So we don't know the hypotenuse. So we're supposed to do the calculation first. So what triangle we're considering? We are considering the triangle BCD. In that, BC square is equal to CD square plus BD square. And CD is what? 8 square plus 15 square. Okay, 64 plus 225. That is what? I think 17. 289 is 17. BC square is 289. So BC must be 17. So this is 17. Now tan B is what? Opposite by adjacent. 8 over 15. 8 over 15. You can't simplify further, so you can leave it. And this one, sine square B plus cos square B. Let's see. Okay, before that, we will calculate the values of sine B. Sine B. Okay, what is sine B? Sine B, this one. If you consider this angle, sine B is opposite by hypotenuse, 8 over 17. And cos B, that is what? Adjacent by hypotenuse, 15 over 17. Then, according to the sum, sine square B plus cos square B. Okay, so sine square 8 over 17 the whole square plus 15 over 17 the whole square. Then 8 square plus 15 square divided by 17 square. Obviously, this is also 289. 289. So what it comes? It is 1. Actually, this is an identity. Okay, guys, I hope you got clear with this concept. Now, let's move to the identities. Okay. So what are the identities? We have lot of identities out there, but as of now, we will see 3 identities. What are the 3 identities? One is sine square theta plus cos square theta equals 1. So this you can write 3 ways. One way is, this is one way. The other way is what? Cos square theta can be written as 1 minus sine square theta. And sine square theta is equal to 1 minus cos square theta. So this is one identity. And the next one is secant square theta minus tan square theta is equal to 1. This also you can write in a different way. Make secant square a subject then what happens? It becomes 1 plus tan square theta. And if you make tan square a subject, then secant square theta minus 1. So you can write this way. Similarly, this one, cosecant square theta minus cot square theta is equal to 1. So this, how come you write? Cosecant square theta is equal to 1 plus cot square theta, and cot square theta is equal to cosecant square theta minus 1. So these are all called identities. We have so many formulas are there, but for your grade, these three, if you know, that is fine. Okay.
Okay, ma'am.
Okay. Okay. Then what else? So one more concept I would like to teach you, that is complementary angles. Have you heard the word complementary angles?
Yes, ma'am.
So what do you mean by complementary angles?
Sum of two angles equal to 90 degrees.
Okay, but in trigonometry, we can write complement of one trigonometric ratio is in terms of other. For example, sine theta is equal to cos of 90 minus theta. So for example, sine 30 is given. You can write cos of 90 minus 30, that is equal to cos 60. So what is sine 30 is equal to cos 60. So you can write sine 30 as cos 60 if the sum demands. Okay, so both are equal. These two are complementary angles. Similarly, you can write the complementary angles for the rest of the trigonometric ratios also. Example, cos theta is equal to sine of 90 minus theta. Similarly, tan theta is equal to cot of 90 minus theta. Then cosecant theta is equal to secant 90 minus theta. Secant theta is equal to cosecant 90 minus theta, and cot theta is equal to tan 90 minus theta. So these are the complementary angles you should know. Okay, okay. We will see using this concept how to apply in a sum, that we will see. Okay. Okay. So, okay. See, for example, if the sum is given. Okay. So how to solve these kind of sums? So to solve this kind of sums, we supposed to know the concept of complementary angles. Tan 28 over cot 62. So you can change this into complementary angle. So this can be written as cot of 90 minus 28. This denominator you write as it is. Then this is what? Cot 62 divided by cot 62. If you cancel, this is 1, isn't it? It becomes very easy. Similarly, the second sum. So what is given? Tan 35 plus cot 55 plus, this is a proving sum. No, it is a wait. Cot 78 divided by tan 12 minus 1. You just apply the concept of complementary angles. So tan can be written as cot 90 minus 35 is 55. This one, you don't want to change. You should not change both the denominator. Any one, if you change, that is fine. Okay, then this one is cot 12 divided by tan 12 minus 1. If you cancel out, 1 plus 1 minus 1, and 1 is the answer. Okay, the same way you can work out all the sums. Okay, this one, third sum, this is a bit different. I would like to do that sum also. Tan 23 degree, tan 42, and tan 48, and tan 67. Okay, so what I do, I change this into complementary angle. So cot of 90 minus 23 is what? 67, isn't it? So cot 67, you leave this, don't change this. Then you change this one. You change this one into complementary angle. Tan 42, this you can write,
48.
yes, 48. And this one you don't need to change, you write as it is. And tan 67, what happens? I told you, right? So tan theta is equal to 1 by cot theta, or cot theta is equal to 1 by tan theta. So either way you can write. So tan theta times cot theta, if the angles are matching, you can cancel. Okay, so you can cancel this, this and this, and this and this, then the answer becomes 1. That's it. Okay, guys. Okay, then apart from this, for some standard angles, you should know the trigonometric ratios. Okay, for example, theta is at 0 degree, 30 degree, 45, 60, 90. These are in degrees. If you want to mention it in radians, that also you should know. Okay, that is 0 radians. This is pi by 6. Pi is nothing but 180. 180 by 6 is what? 30. Pi by 6, pi by 4, pi by 3, and pi by 2. Okay, then sine theta. Sine 0 is 0. This is half. This is 1 by root 2. This is root 3 by 2. And this is 1. Just put a reverse of sine. You will get cos values. Okay, that is a trick you can do it. See, 1, root 3 by 2, 1 by root 2, and half, and 0. Then for tan, I told you, no, tan is sine by cos. 0 by 1 is what? 0. Half by root 3 by 2 is what? 1 by root 3. That way you can, if you don't remember, you can do this way. And this is root 3, 1 by 0. There is no such number, isn't it? So it is not defined. Okay. So the basic, these angles you should know. Okay. These are all very, very important. You should know this. Okay. That's it. Okay, based on these concepts, we do some proving sums. Okay, let's see, is there any proving sums? These are complementary angle concept. Okay, we will see some proving sums. Okay, this one. Proving sums, or you need more practice. Okay, there is no specific method. Only by practice you will get ideas. Okay. So first sum we do. So here you want to prove that 1 plus cos A divided by sin A equals sin A by 1 minus cos A. Okay, see, how do you prove a sum? So this is LHS, left hand side. This is RHS. The way you prove, you can take LHS and bring to RHS, or else you can start from RHS and bring to LHS, or else start from LHS and stop at particular step, and start with RHS, stop at particular step, and equate both the things are equal. So either way, so that is up to you. You can, whatever method you are comfortable, you can follow that method. Okay, so I start with the LHS, left hand side. Okay, so 1 plus cos A divided by sin A. Okay, so this one, what is the idea? What I do, so here sin A is there. I want to make the numerator sign. How come I make the numerator sign? To multiply with the conjugate. Conjugate means the second term is negative. Okay, I think in 9th standard students, you must have studied rationalization, and for that you have to multiply with the conjugate, right? So what I do, I multiply the numerator and the denominator with 1 minus cos A. What happens? What happens? It becomes A plus B, A minus B. That is what? A square minus B square, isn't it?
Yes, ma'am.
Yeah. And then sin A, 1 minus cos A. Now 1 minus cos square A is what? It is an identity, isn't it? So you can write instead of 1
Sine
minus
square
cos square A, yeah, it is
Sine
sine
square
square A divided by sine A times 1 minus cos A. Now you can cancel out whatever possible. Okay, so what is left? Sine A by 1 minus cos A, isn't it? So that is our HS. That's it. Hence proved. The proving sums are very, very interesting, but you need more practice. Okay, guys, I hope you understood. Okay, is there any doubts? You can ask me. Swastika, and then who else? I don't know. Would you like to ask any questions? Yes. One more sum. Okay, sure. Shall we do this sum, or yeah, this one, or any other? Okay, I do this one. Okay. Okay, this 1 minus sine square A times secant square A equals 1. Okay, in this also what I do, I take LHS. What is LHS? 1 minus sine square A times secant square A. 1 minus sine square A is what? Cos square A times, yeah, exactly. Very good. What is secant square? That is actually 1 minus 1 by cos, isn't it? Secant is 1 by cos. Yeah, you can cancel that straight away, but if you wish, you can write this way also, no issues. So you can cancel this cos square, what it comes? 1. That is RHS. Hence proved. Okay, that's it. What's Swastika? Is there any doubts? Do you need to ask any questions?
No, ma'am.
Okay. Okay, thank you. Thank you.